Hey guys, welcome back to another video. Today I'm going to be taking on LeetCode 881 Boats to Save People. This is part of my raw and authentic LeetCode walkthroughs playlist, and so because of that I haven't done this problem yet, and I'm just going to do it based off intuition. So this is a medium problem. You were given an array people where people and the index, so the number represents the weight of that person, and an infinite number of boats where each boat can carry a maximum weight of the limit. Each boat carries at most 2 people at the same time, provided the sum of the weight of those people is at most limit. Return the minimum number of boats to carry every given person. Okay. Okay, let's think about this. So I guess let's just go through examples first. So these added up is 3. That's at most, so that includes the value for the limit, so that works. 1 boat. Here, 3. Well, this guy. Okay, so a hint that I'm already picking up here is the heaviest dude. If it they're already going to need a boat to themselves if they equal to the limit. But I presume if you got rid of the 3, you'd always want to check the heaviest person with the lightest person and see if the lightest person can squeeze in with the heaviest person. Otherwise, just throw the heaviest person on a boat of their own and go from there. So here, 3, 5, 3, 4. Each of them needs their own boat. Okay. So basically what I was trying to say is, say we had an example that was like 1, 4, 5. Okay, let's say 6 as well. And the limit is 6, right? Here, I'm just gonna make this nice and neat so that it works out nicely. So the limit is 6, right? So what we'd want to check is, okay, start at this one, okay? Like, we already know that 6 is gonna have to go on his own. Like, we already know, right? So like if we have boats. This is like a variable that we will have and we will increment whenever necessary. But like, let's say we have boats, right? So we already know the 6 is going to go on his own. So like, let's just get rid of him, and boats can already be at 1. Now let's check 5. Can 5 go on his own, or is there space? Well, there's 1 space. Now let's check the lighter end. The reason I'm already assuming that it's lighter is it's sorted is because like we can sort. So, even though clearly they won't give us it sorted, we can sort it, and that would make it a lot easier. So now we know the 5 can already go with the 1, and because of that we can just get rid of the 2, and then, make it 2, and then get rid of those 2. And then once again we check the heaviest with the lightest, and oh, they can go together too, so throw those together. Bang. Easy. Okay, honestly, not a horrible question. I think I can get this one. And I think I have the right intuition, hopefully. Let me think. Yeah, because like, even if, say, the limit is 6, right? The limit is 6, and let's say like you have like 3, 3, 3, 3, and 5, right? Like, if you check 5 with the lightest one, and they're more than 6, you already know 5 is going to be on his own. You already know it. So then you can get rid of that, and then, yeah, that's obvious. That adds to 6, so that's 2 boats, right? So hopefully not too bad. So let's start by creating boats. Oops. And then what we should do here is we should say, okay, so we want to compare, people dot sort. So we're going to sort people by the integer, and then what I'm going to have is we're going to have 2 pointers. So essentially, like, if I bring back that example, I think it was 2, 4, no, 1, 2, 4, 5, 6, right? So we're gonna have 2 pointers. We're gonna have one on the 1 and one on the 6, and check if when you add them up, are they less than or equal to the limit? And if they are, then we're just gonna throw them on the same boat, and we're gonna bring both pointers in by 1. Otherwise, okay, I'm assuming everyone can fit on the boat. There's not going to be, like here, for example, there's not going to be a 6 that can't fit on the boat. Yeah, okay, beautiful. So the limit's always going to be greater than or equal to the weight of a person. Okay. So then in that case, yeah, just like have the pointers, and if, so we're always going to be throwing the heaviest person on the boat, and then we're going to try to squeeze in a lighter person if we can, otherwise no problem. Okay, I'm going to leave this here just in case. I will just comment it out in case I want to come back to that. So we'll say for, oh yeah, I have to set my pointers, I forgot. L equals to 0, and right is going to be the length of nums minus 1. Okay, that's good, right? Just want to confirm. 0, 2, minus 1, 1. Okay, beautiful. So now I'm going to say, what should the number be? Okay, I'm trying to say while, right? So we'll say like while, what would the last case be here? So like we'd have the 6 go alone, then we'd have the 5 and the 4. Then we'd have a 2 and a 4, and they would go together, and then we'd decrement this and we'd increment that. So I guess we could say while L less than R. Maybe greater than. I don't know. I'll figure that out later. But I just want to have a while so I can get the main logic in. So while left is less than right, what we'll do is we will check if, so we want to check if the left and the right are less than or equal to the limit, right? So we want to check if people L plus people R is less than or equal to the limit. How about we do this? We already know we're throwing the heaviest person on. So what if we check if it's greater? Because if it's, let me think about this for a moment. No, I'm not thinking about that right. If it's less than or equal to, then we're gonna throw the left. We're gonna throw the left person. So we're gonna increment this by 1. And I could do this, but the thing is, we're already throwing. We're gonna throw the heaviest person on. So we can just bring it down here, I think. So we're gonna increment R no matter what, because we're throwing the heaviest person on. And if we can squeeze in the left person, then we will, no problem. And then we just increment boats. Okay, let's see how this looks. Oh, oops, nums. I'm used to seeing nums whenever there's an array of nums in Python LeetCode problems. List index out of range. Oh, sorry, we don't increment R, we decrement R. Oops. Let's see. Okay. Let's think about this. What's gone wrong here? Let's do like a little example, right? So we know boats is 0. Okay, I'm just gonna leave boats as 0. So let's see, boats equals to some value, right? So what's gonna happen here is we're gonna say while L, I'm also gonna have, okay, this is limit, right? And this would be left, and this will be right. Okay, and I'm just gonna basically just like try to run this code over this question. So left is 0, this should be 0, 1, 2, 3, 4, okay? And boats is 0. So what's gonna happen is if people L plus people R is less than or equal to the limit, then increment L. This is not true because this is gonna equal to 7, which is greater than 6. So we're just going to decrement R. So R is now going to become 3. And boats is going to get incremented to 1. Okay, that makes sense. We've used one boat. Now 6 is gone. Okay, now we're at 5 and 1. Now here, if people L plus people R less than, this is true. So what's going to happen is we're going to increment L. We're going to increment L. We're going to decrement R. And when we do that, we also increment boats. Okay, this makes sense. So now we have our indices at 1 and 2. And if we this works out properly. So L will get incremented, right? L will get incremented. So this should become 2, this will become 1, this will become 3. And then after that, L is now greater, so the code stops and boats is 3. Okay, so under that example it works. Let's try one of these ones where it doesn't quite work. So 3, 2, 2, 1. I'm going to automatically sort it. So it's 3, 2, 2, 1, 2, 2, 3. The limit is 3. And let's just readjust every value. Up to 0. This is 3. Okay. So now what's going to happen here is we're going to go through and we're going to be like, okay, so let's see. I'm going to just look at this now. I'm going to ignore this completely. So let's see. What happens here is we have 1, 2, 2, and 3. So 1 and 3 are greater than the limit. So we're going to leave this alone completely. And so what happens is we're just going to decrement R, and we're going to increment boats. So now our pointers are here and here, and now we're going to check, does this work out? Okay. Okay, I think I might see the problem here. I think it's just this. Okay, I'll get to it. So we have R is here and we have L is there. So once again, R and L, these are going to add up to 3, which is less than or equal to the limit. So we're going to increment L, and we're going to decrement R, and we're going to increase the boats. So, but now what's happening is this is already cutting short, but we still have one value, one person to look at to put on this boat. So we should probably throw an equal sign there, because that will get the case where there's two, like where the numbers, I guess this would just be for any even number, except here, I guess. But I guess any even number where actually that doesn't really matter. It just matters that the pointers meet. And so yeah, equals to makes sense here. Okay, let's see if this runs now. I just want to make sure I didn't change any of the other values. Okay, let's see. Beautiful. Okay, awesome. Okay, let's see if submitting now works. Hopefully it does. Okay, awesome. Nice. Good runtime and good memory complexity. Alright, well, that's the end of today's video. I hope you guys enjoyed, and I hope you guys learned something new. If you guys think there's a better way to solve this problem, please let me know down in the comments below. But that's the end of today's video, and I will see you guys in the next one. Bye-bye.